Next is the cumulative distribution function. Now, sometimes a lot of things can be done with CDF rather than a PDF. What PDF represents is the probability at one point, or probability of one, or for probability mass function, probability of one variable, while CDF represents the probability of every variable or the whole length up to that point. So what PDF for, so CDF for a random variable x, it is represented by ft is equal to probability of x less than equal to t. So all the probabilities are summed. So if x has a PMF of fx, then by definition f of t is going to be sum of x less than or equal to t fx, sum of which is basically nothing else but sum of all probabilities of x up to t. And then the other one is, if the, this is the PMF, if the PDF is fx, then f of t is equal to minus infinity to t fx dx. Now let's talk about the CDF of discrete distributions. So if x is a geometric distribution, for example, we are tossing a coin till we get the first head.
Do you have a lint remover?
Tossing a coin till we get first head. Then if it has a parameter p, the f of x, we know that for geometric distribution the PMF is given by p 1 minus p x minus 1, for x is 1 2 3 dot dot dot. So f of t is going to be sum of all probabilities x is equal to 1 to t of xx. This, since p is the constant here, p is going to come out of it, and it's going to be x is equal to 1 to t 1 minus p x minus 1. Now this is a geometric series because x can be really anything if you want to do a PMF, and if you add geometric series up to the tth term, if you add geometric series up to the tth term, you will get is the PF of t is going to be p 1 minus p t upon 1 minus p. This is just a geometric series formula, and now you can solve this as p 1 minus p t 1 minus 1 plus p. This and this gets cancelled, and this gets cancelled with this. So you are left with f of t is equal to 1 minus p t. So for any positive integer, this is the f of t for a geometric series distribution. So that's how you will calculate this. But what if we say, and this is important property for a discrete variable. So if you have a variable which is between 3 and 5, so if s is, if you have a discrete variable number named t and the other one is t plus 1 and the s is less than this but more than or equal to this, then the PMF of s is going to be the CDF of s is going to be the CDF of t, or f of s is going to sum of all the values of f x, which is basically going to be x is equal to 1 up to t fx, not t plus 1, even if it lies between t plus 1. So if it is between 1 and 2, then it will be CDF of 1. If it is between 2 and 3, then it will be CDF of 2. Next is the CDF of uniform distribution over an interval. So CDF of a uniform distribution over an interval. Now see, x is a uniform distribution over an interval a and b, where a is less than b. So the PDF of such a uniform distribution, if it's b here and a here, is going to be given by PDF f of x is going to be 1 upon b minus a. Now why is this so? Now if this area is always going to be 1, right? So area is going to be this time multiplied by this. So area is going to be length times height, and that is going to be 1, and the length is b minus a times height is going to be 1. Thus height is going to be 1 upon b minus a, and height is nothing but f of x. So that is why the PDF of a uniform variable is given by 1 minus b minus a. Okay, so then what going to be f of t? F of t, and t is any value between b and a and b. It's going to be sum of all values negative infinity to t f of x dx. But we know that f of x is equal to 1 upon b minus a, where x is more than a and less than b. And we also know that f of x is going to be 0 for values less than a, and it's also going to be 0 for values more than b. So f of t is negative infinity to t f of x. That will come out to be t minus a upon b minus a. And well, it's hard to do this integration, but it's logically it makes sense, because if you think of it, if you think of this in this box here, where this is b and this is a and this value here is t, so we are talking about this area here, and the area of this area is your f of t. So f of t is going to be t minus a divided by b minus a would be your area. So that's and obviously the f of t is going to be 0 when it is here, and f of t is going to be 1 for anything which is more than, for t more than b, it's going to be 1. So that's the CDF of the for uniform distribution. But what about exponential distribution? So next is going to be CDF of exponential distribution. So let's say that x is an exponential distribution. So exponential distribution, expected value of x is lambda. That is just the property of exponential distribution, and in that case the f of x is going to be given by 1 upon lambda e to the power minus x upon lambda. So what is an x is more than or equal to 0, so this is applicable for positive values only, and f of x is going to be 0 if x is less than 0. Okay, so because of which f of t is equal to 0 if t is less than 0. For any negative value, the chance that the random variable is smaller than that value is 0. So now if you want to calculate the f of t, all you have to do is minus infinity to t f of x dx for t more than infinity. So since negative infinity to 0, the integer is 0, we can also write this as 0 and t f of x dx. Now so and that can be written as 0 to t 1 upon lambda e to the power minus x upon lambda dx, and that you can integrate very easily, and it will come out to be f of t is equal to 1 minus e minus t over lambda for t more than or equal to 0. So this is the CDF of the exponential distribution. So exponential distribution and uniform distributions, for them PDF can be integrated, and you can use analytical methods to get the CDF. For some distributions like normal distributions, it is not possible, and that's why we have to use the numerical tables to solve that.